Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
Hook. This one type of question, a two-stage conditional probability using a tree, lost more method marks than any other on last year's AQA higher paper. Students often write the wrong fraction at the end and can't get method marks back. Sound familiar? If you've ever stared at a tree and wondered where that division comes from, stick around. This episode fixes that in minutes.
Promise, in the next few minutes you'll learn how to draw a clean probability tree, how to label every branch so the examiner understands your method, how to read off joint probabilities and convert them into conditional probabilities, and a 1-minute check you can use under exam pressure to catch mistakes. The concept starts simple. Imagine a two-stage experiment. First, you choose one of two bags at random. Then you pick a ball from the chosen bag. A probability tree is a picture of those sequential choices. Each split shows the possible outcomes at that stage and their probabilities.
So, the tree is just the sequence in picture form? I always thought it was just drawing lines and numbers.
Exactly, but it's more than drawing lines. Each branch is a conditional path. The key rule, to get the probability of a particular path happening, you multiply the probabilities along that path. So, if you pick bag 1 with probability 1/2, then draw a red ball from bag 1 with probability 3/5, the path bag 1 then red has probability 1/2 times 3/5 equals 3/10. Multiplication is not a trick. It's the definition of joint probability for sequential independent choices. Important labeling conventions. Write the name of the event on each branch, and next to it write the probability, ideally as a fraction. For example, left branch, bag 1, 1/2. Then from bag 1, a branch red 3/5 and blue 2/5. Do the same for bag 2. That way, whoever marks your script knows exactly which probability you used at each step, and examiners love that clarity. One more naming tip. When you want a conditional probability, like P bag 1/red, write that label on the right-hand side of the tree, or in a short sentence below the tree. State explicitly, P bag 1/red equals P bag 1 and red divided by P red. If you show the division, you give yourself method marks, even if your arithmetic slips. Let's do numbers. Example setup. Bag 1 contains 3 red and 2 blue balls, so P of red given bag 1 equals 3/5. Bag 2 contains 1 red and 4 blue, so P of red given bag 2 equals 1/5. You choose a bag at random, so P of bag 1 equals P of bag 2 equals 1/2. Draw the first split, bag 1, 1/2, and bag 2, 1/2. Then from each write the red and blue branches with 3/5, 2/5, and 1/5, 4/5, respectively. Okay, so to get the joint probability for bag 1 and red, I multiply 1/2 by 3/5 and get 3/10. For bag 2 and red, it's 1/2 times 1/5 equals 1/10. Then total probability of getting a red ball is 3/10 plus 1/10, that's 4/10 or 2/5. Perfect. Now the conditional question, that's the trap. Given that a red ball was picked, what is the probability it came from bag 1? That's P bag 1 given red. Use the formula, P bag 1 and red over P red. Numerically, that's 3/10 divided by 4/10 equals 3/4. Notice the tens cancel. It's the ratio of the joint probability from one branch to the total probability of the observed event. Mark scheme mapping. This is typically a 4-mark question on the higher paper. How marks often break down: M1 for drawing the tree or stating P of bag 1 and P of bag 2, M1 for writing the conditional probabilities on the second stage, M1 for calculating joint probabilities by multiplication, and A1 for the final conditional answer after a correct division. If you show those steps, you can pick up method marks even if your final arithmetic is slightly off. Common exam mistake. Mixing up P of A given B with P of B given A. In our example, some students write P of red given bag 1 when the question asks for P of bag 1 given red. The notation matters. Always say in words what you're calculating. Probability it came from bag 1 given red. Writing that sentence avoids the wrong fraction being used as numerator or denominator.
Guilty. I've written the wrong conditional label before. Small mistake, big consequences.
Worked example, GCSE style, with the marks called out as we go. Question. 2 bags are chosen at random. Bag 1, 3 red, 2 blue. Bag 2, 1 red, 4 blue. You choose a bag at random and pick a ball. A. Find P of red. B. Given the ball is red, find P of bag 1 given red. Step 1. M1. Write P of B1 equals 1/2, P of B2 equals 1/2, and label second stage probabilities P of R given B1 equals 3/5, P of B given B1 equals 2/5, P of R given B2 equals 1/5, P of B given B2 equals 4/5. Step 2. M1. Calculate joint probabilities. P of B1 and R equals 1/2 times 3/5 equals 3/10. P of B2 and R equals 1/2 times 1/5 equals 1/10. Step 3. M1. Add for P of R equals 3/10 plus 1/10 equals 4/10 equals 2/5. Step 4. M1/A1. Conditional. P of B1 given R equals 3/10 divided by 4/10 equals 3/4. If you show each of those steps, you'll usually pick up 3 method marks and the final accuracy mark.
If you're short of time, write down the joint probabilities first. Even if you don't finish the division, the examiner can often award M marks for the correct joint values. That's method credit visible on your script. Quick win. A 2-second check to catch almost every slip. After you draw your tree and calculate joint probabilities, circle the branches that lead to the event in question. In this example, the 2 red branches. Add their joint probabilities to get P of red. Then perform your conditional division. If your conditional probability isn't a fraction of those circled joint values, you know something's wrong. Labeling shortcut. Write the joint value next to each terminal node. Then under your division, write the explicit formula. P of bag 1 given red equals joint for bag 1 and red divided by the sum of joint red branches. That single sentence gives away clarity and gets you method marks. So the 2-second check is circle, add, divide. Circle the relevant branches, add them to make the denominator, use the branch you want as numerator. Simple and exam-proof. I'll use that next time. Extra quick checks. Check that the probabilities on each initial split sum to 1. For a fair choice between 2 bags, that's 1/2 plus 1/2 equals 1. Also check that for each bag, the conditional probabilities for the second stage sum to 1, like 3/5 plus 2/5 equals 1. These small sanity checks catch a surprising number of errors. When you're writing answers, think in terms the examiner uses. Label things clearly. M1, M1, M1 steps aren't written on the exam paper, but you can mirror them. Tree drawn with P of B1 equals 1/2, P of R/B1 equals 3/5 is effectively the same clarity an examiner needs to give method marks.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.